Scientific notation is a method for rewriting very large numbers and very small numbers in a more compact way. These very large numbers and very small numbers have a lot of zeros as placeholders to tell us how large or how small the number is, and scientific notation is a way for us to avoid having to write all of those zeros over and over again. It can be tedious. It's easy to make a mistake and lose a zero or add a zero, and it just makes all of your calculations more difficult. So our process that we're going to use to take a regular number, sort of standard number you've seen, and rewrite it in scientific notation is to, number one, identify the significant figures. We need to know we're only keeping the significant figures. We're throwing out all the placeholders. Then we want to move the decimal to the right side of the farthest left non-zero digit, basically the largest number, the largest non-zero number that's farthest to the left. Whenever you're moving your decimal place, it's like you are multiplying or dividing by 10 each time. And so whenever you shift your decimal place, you count the number of decimal places that you move, and that's going to be the power of 10 that you are adding to your number. If you're moving the decimal from right to left, it's like you are dividing by 10, and so you need a positive exponent. You're basically multiplying that 10 back in. If you move from left to right, you'll have a negative exponent, and you're going to end up with a number like this, where a is a real number. Basically, it's going to be a number between 1 and 10 with some decimals, and then you're going to have 10 to some integer value. Let's check that out. Here, if we have a explicit decimal point. An explicit decimal point means that the decimal point is right there. We can see it. It's explicitly written. We said, number one, we want to keep the significant figures only. So I look here, and my significant figures in this case are those three significant figures. Then we said we want to move the decimal place just beside the farthest left non-zero digit. So I look at my significant figures here. This is the non-zero number that's farthest to the left, and so I want to end up with my decimal point just beside that, so that here I have a number that is between 1 and 10. I'm going to have to move my decimal place here 1, 2, 3, 4, 5 places, and so I'm going to end up with 2.18 times 10 to the negative 5. I moved my decimal place from left to right, and so I have a negative exponent. This is like I'm multiplying by 10 5 times, and so I have to divide by 10 5 times to counteract that effect. I can do that again here. First, I look at my significant figures. Recall that these are still significant figures. If we hadn't measured these to be 0, we would have just omitted them, so they are significant. I know where I want my decimal place to be, and so I go 1, 2, 3 places there. And I have 2.00 times 10 to the negative 3. You're keeping all of your significant figures. Your significant figures in your scientific notation should match the sig figs you have in the original number. Usually we're using scientific notation in numbers like these. These are very small numbers. This is a very small measurement with a lot of placeholders. But any old number can be written in scientific notation. This is still an explicit decimal point. We can still see it right there. In this case, we have 4 significant figures. We're going to keep all of those. We also want to put our decimal point right beside the farthest left non-zero number that we have, just like we've done before. In this case, our decimal point is moving 1 to the left, which is like we're dividing by 10. And so we're going to have a positive exponent, a positive power of 10, to counteract that effect. So we move the decimal place to the right, and we got negative exponents. We move the decimal place to the left, and we got a positive exponent in that case. We have the same number of significant figures as we had in the original number. Other numbers have implicit decimal points. They're not written, but they are implied. They are implicit. For example, the decimal point is always implied to be at the end of the number, even if it's not directly written. We're going to find our significant figures. There we have 4 significant figures. We know where we want to put the decimal point. It's going to go just beside the farthest left non-zero number. And so I'm going to go from my implicit decimal point to where I want the decimal point to be. And I've moved 5 decimal places to the right. I'm going to preserve my significant figures, and 5 decimal places is going to be 10 to the power of positive 5, since I'm moving from right to left in this case. Same idea over here. I've got 1 significant figure. I've got an implicit decimal point there. And I want to put my decimal point right by the largest non-zero number, the only non-zero number in this case. So I'm going to move that 2 places. And notice again, same number of significant figures as I started with, same number of significant figures as I started with. Lastly, note how I've shown my procedure here. I've shown the identification of the significant figures. I've shown the moving of the decimal point. This is the correct process for you to demonstrate your understanding of how to write numbers in scientific notation.